This is the video for your notes on SOL 8.13 on graphs and scatterplots. You'll need one pencil to complete these notes. A graph that uses bars to display the number of items in each category. So we have the categories at the bottom, sometimes they're on the side, but there's bars to show how much each category has. So this type of graph is a bar graph. And it's best to use a bar graph if you want to show how much or the number of items, depending on what the graph is. In this case, the amount of money. So the number or amount per group. So in this bar graph, we could see how much money USA has in this situation. We could also compare how much money USA has to how much money India has. So a bar graph would also be good if we wanted to find the differences between the different categories. So the differences between UK and India or USA and UK is easily seen. Now the next one's a type of bar graph where the categories are ranges of numbers, and the bar's height depends on the number of items within that range. So we don't see any gaps in this one because it's more of a continuous graph. So if I want to see that a little bit more than 21 items have a value between 100 and 150, then it kind of shows the distribution or of the data points in your graph. So a histogram is best used if you want to show the number of items, data points, or people, whatever your graph is showing, that fall within a specific range. So the number ranges are your actual categories on the bottom. And you want to know how many items fall within each of those number ranges. A graph that best shows trends of data over time. So this is best used, so we see that we have a continuous line that goes all the way across the graph, and this is called a line graph. And a line graph is best used if you want to show a trend over time, and you want to track it over a period of time. So Monday, Tuesday, Wednesday, Thursday, Friday, we see that this graph is tracking something over those days. A graph that shows portions of data. This shows the fraction, percent, or the part of the whole data that each category consists of. There's two different names for this. Some people call it a pie chart, while others call it a circle graph. The most commonly used one in mathematics is going to be the circle graph. So we see a circle there, it is a circle graph. Now, it's easy to see which category has the most items or the least items. 40% would be the most, 10% in this case would be the least. But it's mainly used if you want to find the part of the whole group. So you're comparing one of the groups to the whole group to see what part of the whole circle or what part of the whole group that category makes up. So the part of the whole group is being shown, or you could see the fraction or the percent for each category. Points are plotted to show the relationship between two sets of data. So each point has two things associated with it, and those points are scattered across the graph. So this is called a scatter plot. So it's best used to show if you're comparing two different things. So each point there is a person, and that person has a weight and a height. So you're comparing different people's weights versus their heights. And here it shows that as their weight increases, their height increases. But that might not always be the case. I think that as their height increases, their weight probably increases. And you want to see any relationships between those two sets of data. So we are comparing two sets of data at once, and we want to find trends or correlations. Now, a correlation is just a connection between those two different sets of data. So a relationship between the two sets of data on a scatter plot where as one set of data increases, the other set of data also increases. So we see that the points are moving upwards, and if I looked at that line, it would kind of look like that line has a positive slope. And if we have a positive slope, then the connection between those two sets of data is going to be a positive correlation. Now for the next one, a relationship between two sets of data on a scatter plot where one set of data increases and the other set of data decreases, we see that the points are moving downwards, and we draw a line there. It looks like it has a negative slope. So this situation on the scatter plot has a negative correlation. Now, if you look at a relationship between two sets of data on a scatter plot where one set of data increases, the other set seems to just be random, this has no correlation. I don't see what type of graph is being shown. We see that we have a few different bars, and each bar has a category, so this is a bar graph. And it's asking what kind of information is being shown. So if I look at the title, I see that it's talking about a basketball game, and it's showing how many points each of those people scored in a basketball game. So it's showing the number of points each person scored in this basketball game. Now the next question is asking who scored the most points. So to see that, we're going to look at the biggest bar, and we see that Bill scored the most points, and Bill has the most, and he's at 40 points. The least points would be the smallest bar, so Ed has the smallest bar. And it's asking what's the difference between the lowest and highest scoring people. Well, Bill scored 40, and Ed, well, he's kind of in between those two amounts, so the number that's in between 10 and 0 in the middle would be 5. So we see Ed only scored 5. So the difference between 40 and 5 would be 35. So it's pretty easy to see that difference. And we could also kind of count up to 5 and then add 30 more. So this next one is saying how many total points were scored in this basketball game. And we would need to know how much each person scored. So Adam scored in between 10 and 20, which is 15. Bill scored exactly 40. Cody scored 10. Dan scored 30. And Ed, we know, scored 5. So if we want to know the total number of points in this situation, we would add up each of the categories to see how many total points. So 15 plus 40 plus 10 plus 30 plus 5 would give me the total amount. So 15 and 5 is 20, plus 40 is 60, plus 10 is 70, plus 30 would be 100. So we see that there was a total of 100 points this game. What type of graph is being shown here? Well, this looks like a bar graph, but the categories are actually ranges. So this is a histogram. And the type of information being shown, I see the title says CDs owned, and the frequency of people owning a certain number of CDs is kind of what this is looking at. So the ranges are the number of CDs, and the frequency is how many people actually own those. So we're showing the number of people who own CDs within that number range. So within the number range that you see at the bottom. So we could see the 0 to 9, there are 4 people that own between 0 and 9 CDs. And that's the range that's the most popular. The most people own between 0 and 9 CDs because that's the biggest bar in this graph. This next one's asking how many total people were involved in this survey. So you see that 4 people own 0 to 9, 3 people own 10 to 19 CDs, 1 person said they owned 20 to 29, and 2 people said that they own 30 to 39 CDs. So 4 plus 3 plus 1 plus 2, and I see there's 10 total people that were involved in this particular survey. How many people own less than 20 CDs? So we see that 20 to 29 is in this bar, so 0 to 19 would be less than 20, so we're going to combine those two bars, and we see that 4 plus 3 gives me 7 people that own less than 20 CDs. Here we see a line that's going across a few days and tracking data across a few days. So this is a line graph. And if we look at the title, it says temperatures of planet swag. On the left, you're measuring in degrees Fahrenheit. And at the bottom, you're tracking those degrees Fahrenheit on planet swag across a 5-day period. So what's being shown, we're seeing temperatures over a 5-day period on planet swag. So it's pretty easy to see that the temperatures are going down for the most part. The warmest day would be the highest point, so day 2 has the highest point at 70 degrees Fahrenheit. And the coldest day would be the lowest point, so that's kind of in between 58 and 62 on day 5, and 58, 59, 60, 61, 62, so 60 is the number in the middle, and we see that day 5 is actually at 60 degrees Fahrenheit. This next one's asking what's the difference in temperature between the warmest and coolest days. So you would need to find the warmest day, then the coolest day, and subtract to find the difference of 10 degrees. So you can kind of see that it goes up 5, 10 different degrees. So day 1 is 68 degrees because that's in between 66 and 70. Day 2 is 70 degrees, and day 3 is in between 62 and 66, which would be 64 degrees. And day 4 is a little more interesting. It's in between 64 degrees and 62 degrees, so day 4 would actually be 63 degrees. And day 5, we know, is 60 degrees. What type of graph is being shown here? Well, we see a circle, so it is a circle graph. And it's asking what type of information is being shown. Well, I see that the title says most popular sports, and each of the different categories are different sports: gymnastics, baseball, basketball, track, soccer. So there's not as much information on here, but it's showing us the percent of people who play these different sports. So we know what portion of the whole group, maybe this is a high school, what portion of the high school plays soccer. And if 100 people were involved in this survey, or the data that's being shown, it's asking how many people played baseball. Well, I see 20% played baseball, so that would mean 20 out of the 100 people would have played baseball, and that would mean that 20 people played baseball. If 50 people were involved in this data, then how many ran track? So track, we have 25%, and 25% means 25 out of 100. So we don't want to know if 100 people so we want to know if 50 people did. So if we kind of divide the top and bottom by 2, 100 divided by 2 is 50, and 25 divided by 2 would give me 12.5. And you can't have half of a person. So this would probably be about 12 to 13 people out of those 50 people played or ran track. What's the most popular sport? We look for the biggest section, which in this case is soccer, at 30%. So we see that the 30% is pretty easy to see. It is the biggest number, but the biggest section is what you might see because you don't always have that percent that is shown on each sector or category. So baseball was 20%, basketball was also 20%, track shows 25% of the participants ran track, 30% of the participants played soccer, and only 5% of the participants did gymnastics. What type of graph is being shown? I see a bunch of points that are scattered across here. So this is actually a scatter plot. And I see beach visitors, and I see the daily average temperature and the number of visitors. So for each point, that seems to be one day, and it shows the number of people who visited the beach on that particular day and how warm it was. So we're comparing for each day or each set of data the temperature of that day, and we're comparing the temperature of the day to how many people went to the beach that day. So we're comparing the daily temperature of a given day, so a random day, to the number of visitors to that beach. If we want to know how many days are being shown on this graph, we're going to count the number of dots. So each of those dots, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different dots mean 11 days. So the general trend of the data is that the data is getting, is kind of moving upwards. And we see that they kind of follow that line. So it makes it look like as the temperature of the day gets warmer, or the average temperature is warmer, it seems to be like as though the beach gets more visitors. So more visitors want to go to the beach when it's warmer. As the temperature increases, then the number of beach visitors increases as well. So we see that this line is going up, and if I were to put a slope on that line, we would say that that line has a positive slope. So what kind of correlation is being shown? This line's going up, so it's going to be a positive correlation. What was the difference between the number of visitors on a day whose average temperature was 84 degrees compared to a day whose average temperature was 92 degrees? So 84 degrees we see is that point, and an average of 92 degrees, we see 92 degrees is about here. So we want to know the difference between the number of visitors on those 2 days. So we have 225 people visited on a day that was 84 degrees, and we see that 450 people visited the beach on a day that it was 92 degrees. So the difference between 450 visitors and 225 visitors, we are going to use subtraction. And 10 minus 5 is 5, 4 minus 2 is 2, and 4 minus 2 is another 2. So it's actually a difference of 225 visitors. Classify the following scatterplots as having a positive, negative, or no correlation. So this first one, there's no direction, so this has no correlation. We see the points are going downwards, or it would look like it has a negative slope, so number 2 has a negative correlation. The points are going upwards for a positive correlation. For number 4, it looks like the points are going upwards. This is a stronger positive correlation. And for number 5, we see the points are kind of closer together to that line, so that's a stronger negative correlation. And for number 6, they're kind of going in a circle, so I don't see a correlation here. A person randomly selected 7 days to record the temperature outside and their water consumption, and they wanted to know if there's a correlation between the two sets of data. So I see 48 ounces and about 99. It doesn't have to be exact, but you need to get it as close as possible. 27 ounces with 85. 48 ounces with 97, 16 ounces with 75, 32 ounces for 92, 25 ounces for 85, and 20 ounces we have 83 degrees Fahrenheit. So we see that it's going up, and that would have a positive correlation. So it seems as though the water consumption increases when the temperature increases. So we recorded the grams of fat and the number of calories in different types of meat and fish, and it asks if there's a correlation between the two sets of data. So fish sticks, we have 3 grams for 50 calories, then we have 9 grams for 190 calories, 7, so 9, get in the middle there and go up to about 190. We have 7 grams with 170 calories. Then we have 10 grams for about 185 calories, and then 7 grams that has 165, and 19 grams that has 245. So we don't have very much data for this scatter plot, but we kind of see that for the most part, it is going up. So I would say that this has a positive correlation. For this next example, a history teacher asked her students how many hours of sleep they had the night before a test. The data below shows the number of hours the students slept and their score on the exam. So we see that the first student slept 8 hours and got an 83. The next person got 7 hours of sleep and 86. 7 hours with 74%. 8 hours with an 88. 6 hours with 76. 5 hours got a 63. A student with 7 hours of sleep got a 90. 4 hours of sleep got a 60. 9 hours of sleep got an 89. And 7 hours of sleep got an 81. So when we plot all of those, we see that they're generally going up. So this is a positive correlation.